Hello, everybody. This is 2016 AP Calculus exam number 4, detailed solution. So let's start reading this guy. It does say that considering this differential equation, so this is one of our AP FRQ type questions, which is manipulating differential equations. They are giving us the first derivative and they want us to find the second derivative, but it must be in terms of x and y. So what's the derivative of x squared? That's 2x. That's right here. And then what's the derivative of 1/2 y? Well, that's 1/2. And then y changes to y prime, which I prefer to write as dy dx. Now, if you stop here, this is not in terms of x and y. This is in terms of x and a derivative of x and y. So you do have to go back and substitute this into the dy dx. Now, if you really wanted to, you could, of course, multiply all this out. I would not recommend it, but if you wanted to, you'd end up with 2x minus 1/2 x squared, and then the 1/2 times the 1/2 would be positive 1/4 y. That doesn't really matter, but you assign your 2 points. I honestly don't know if they would give you 1 if you left it like this. Let's try to err on the side of being a little bit more stringent on your grading. So I'd say let's not give you anything if you didn't move from this step to this step. Okay, that's part A, your 2 points. So moving on to part B. Let y equals f of x be a particular solution to the given differential equation above. So that just tells you that there's an original function y, which can also be called f of x, whose graph passes through -2, 8. Does the graph of f have a relative minimum, maximum, or neither, and justify? Well, first of all, anytime you see particular solution, I would say 3 out of 4 times. That means you're going to be separating variables, but that's not the case here. You just need to find if you have a maximum, a minimum, or neither. So maximum, minimum, or one of these neither things that we've been seeing over the last couple questions. Now, we have the first derivative, so we could probably just substitute that in right away to see if we have a 0. If we do not have a 0 of the first derivative, then we're going to have something that's other than these 3 situations. And then, of course, you could stop right there, and that's neither. So taking that first derivative and substituting in -2, 8, you get a 0. So that means I've got one of these 3 now. So it's not going to be the neither. It's going to be a max, a min, or it still could be a neither if you did have this situation here. A lot of you will be inclined to go with the first derivative test, which means you're going to test a point to the left of -2 here. The problem with that is you don't know what that original function is. So the best way to do this, since you have the second derivative, is just do the second derivative test, which tests for concavity. Concave down, you have a maximum. Concave up, you have a minimum. And if you get another 0, that means you have a point of inflection. That means you have neither. Now that is clearly the best way to go here. So the answer, conclusion here, is going to be maximum. Now the y is because the first derivative equals 0 and the second derivative is negative. So since the first derivative equals 0, you have a horizontal tangent line. And since the second derivative is negative, -4, you know it's concave down, therefore you have a maximum. So this is as simple as you need to say that to justify this. How did I get that actual values? This is all the stuff from part 1, and you're substituting in these values. Now, if you got part 1 wrong and you use the derivative you had in part 1 and you justified everything correctly, they would give you both points as long as you didn't make this a much easier kind of problem. Moving on to part C. Part C says let y equals g of x be a particular solution to the differential equation given g of -1 equals 2, so that's an ordered pair. So -1, 2 in my particular solution, which would be then the antiderivative of this. Find the limit of this stuff. Show your work that leads to your answer. Anytime you have a limit in a FRQ, I would say 9 out of 10 times it's L'Hopital's rule. So first of all, let's look at this whole thing. Before you begin L'Hopital's rule, you need to verify this is an indeterminate form of 0 on the top and 0 on the bottom, or infinity on the top, infinity on the bottom. So we're going to do that. So you take the limit as x approaches -1, so you make this g of -1. When you direct substitution, g of -1 is 2, so you get 2 minus 2. Hey, that's a 0, so that's my numerator. What about my denominator? Well, my denominator is 3 times quantity x plus 1 squared. You substitute a -1 in, direct substitution. That's 0. 3 times 0 is 0. Now, in divvying up these points for this first part, the red part, if you end up doing this as a fraction somewhere on your paper and getting 0 over 0, they are not going to give you all 3 points. They're going to give you 1. When you do L'Hopital or L'Hospital's rule, you must put them separate on separate lines and not make them an indeterminate form. The reason why is because if you get 0 over 0, that means indeterminate, cannot be determined. So if you end up with the answer of -2, it can be determined. So that's a contradiction. That's why you don't want to write this as a fraction. You just want to do them separately. If you did write it as a fraction, you're definitely taking off 1, and you should do that every time you do L'Hopital's rule on a FRQ. So now, what is L'Hopital's rule? Now, you had to somewhere on your paper have shown a derivative. So when you do your derivative, the derivative of g of x is g prime of x, derivative of 2 is 0. And then here, there's lots of ways to do this. The chain rule is probably the best way, although you could FOIL this all out, then distribute into 3 and do power rule. But as long as you end up getting another 0 on the bottom, you're going to be okay. So the chain, using the chain rule here, you bring the 2 in front and make this a 6. Leave the inside, lower the exponent from 2 to 1, and then take the derivative of the inside, which is 1, so you don't need to tack on a chain piece, but you can if you want to. And then, of course, direct substitution. You substitute a -1 in here. -1 plus 1 is 0, and you get, once again, not written as a fraction, written on separate lines as top equals 0, bottom equals 0. Hey, guess what? L'Hopital's rule again. Now, if you didn't get 0 and 0 and you got something else, because you maybe made a mistake in here, you're going to get 1 point for L'Hopital's rule, but you're not going to get the other 2 points. How do you get that full last point? Well, getting the last point, you then once again need to use L'Hopital's rule again. So the derivative of g prime is going to be g double prime. The derivative of this, if you distribute the 6 in, you get 6x plus 1. The derivative of 6x is 6. The derivative of 6 is 0. So you just get this. So now my denominator is 6. The question is, how do you evaluate the numerator g double prime? Well, part 1, this here is all part 1. I actually did distribute that half in, I believe it was, from part 1. It doesn't really matter, but I'm showing all the work here. You're substituting in your -1 for x, so 2 times x, it's 2 times -1. And then don't forget, anytime you see a y, here's a y. In place of that y, you're going to have a 2. So when you work all of this out, you get a -2. So follow the trail here. This is a -2 on the numerator. You could have did a lot of that in your head. Maybe be careful. I would err on showing more work. And then -2/6 is fine. You don't have to reduce on the FRQ. -1/3 is your answer. So really quickly, to justify this again, 1 point, the red point, for showing that you have 0 over 0 on separate lines, not as one fraction, and knowing you needed to take derivatives. And then actually doing the correct derivatives, moving down from here to here. And some students just have a hard time evaluating, and that's how you get that 3rd point, because they don't really know, hey, where do I get this g double prime from? But look around, every part is dependent on previous parts. All right, so that's part C. Here comes part D. Let y be h of x be a particular solution to the given differential equation. Here we go again. But now we got this point, 0, 2, and we're using Euler's method. Okay, so we're using Euler's method starting at 0, and we're going to use 2 steps, and we're supposed to approximate h of 1. So to go 2 steps, each step is going to be 0.5 or half apart. So 0 to 0.5 is step 1, 0.5 to 1 is step 2. So the best and easiest way to do and think about Euler's method is point slope. The old y value, here's like point slope here, the old y value, y that you're trying to figure out, is equal to the old y value, I think I said old here, So it equals the old y value plus the slope times the change in x. So this is just like a tangent line problem. So here it looks like in your point slope form, but you can just probably look at this line and kind of memorize that for Euler's method. Euler's method usually is pretty easy. So if you did something that relatively looks like this, but you made a calculation error, you're going to get this first point. To get the second point, you actually need to get the correct answer. So the correct answer is 5/4, or it can be left like this, unsimplified. So real quickly, just to run through this, the old y value in this case is h, we're calling it h, so it's h of 0, so that's a 2, plus the slope. Now, how do I find the slope? Since this is a particular solution, this dy dx represents my m. So how do I get the slope when h equals 0? Well, 0, 2, your 0 goes in for your x, and your 2 goes in for your y. So that is going to give you 0 in here, 2 in here, half of 2 is 1, so -1. And then your delta x is always, for this problem, going to be half. I went through that when I read this. And then what do you do now? Well, you need the second step. So you're using this 3/2, and you're going to go again. So the old from the last step is the 3/2. Then you're going to be using the point. Now, I'm going to put the point here because my original point was 0, 2, but now my new point is going to be 0.5, or half, comma, my new y value is 3/2. So this is the ordered pair you're going to be substituting in for x and y, and it looks like the answer to that is going to be -half. And then don't forget your delta x is always 1/2. So final answer is 5/4. So if you did something that looks like this, you get the 1 point. And then if you actually did all the correct math, you can kind of look almost at your final answer and you get that second point. Thanks for listening. AP Calculus BC, FRQ 2016. This was probably a little bit more of a difficult question because there's a lot going on.